Hey guys, how's it going? Hope everyone's doing well. I'm just gonna wait a few more minutes for everyone to join and then we can get started. But in the meantime, if you guys have any questions, feel free to drop it in the comments and I'll try to answer that. All right, guys, I think we can get started. Thank you all for joining. Hope you're all having a really nice day. My name is Aditya, and I work on the ecosystem team at MOI and several labs. And this is the first episode of the MOI Builder series. Um, Yeah, so over the next 1 hour, we're gonna essentially go from completely a blank slate to real program running on MOI's.net, or everything from writing code to testing to deploying and verifying on chain. And if this is your first time on MOI, or if you've not used any of the tools before, don't worry about it. We're going to be walking through every single step of the entire workflow over here today. So before we write a single line of code, I want to give you guys an idea to hold on to for the whole session because everything else kind of builds on this one idea. So MOI is participant centric. So most blockchains, all the state, like everyone's balances, everyone's data, it all lives in one giant shared pile that the whole network reads and writes. MOI is built slightly differently. Every participant owns their own identity and their own state. It's a small sounding design choice, but it's the thing that makes the rest of MOI possible. What that essentially means is that, for example, on Ethereum, uh, any data or any kind of state related to assets or um, like ERC20 contracts, all of these, all of the state related to this is stored at a smart contract level. Meaning, I'm an entry in a mapping, you guys are an entry in a mapping for your balances. On MOI, these balances are natively tied to you, to us, the participant. So there's no single smart contract, there's no global shared space. And this applies for all different types of state, not just assets. So, two examples on the screen, which we'll get more into in further sessions, which are the two most important use cases. One is native assets. So, on MOI, assets are part of the protocol itself, not something you build by deploying a contract. And second one is safe AI agents. Um, so agents have a capability of actually getting their own identity, getting scoped revocable authority, and provenance. Agentic provenance is something that is very unique to MOI. So every time an agent performs an action, it cryptographically signs using its wallet, depending on what the interaction is. So every single interaction it performs, you can see an agent's stamp and signature on it. So, if something bad happens, if an agent does something malicious, then you know in real time what it did and when it did it. Um, and yeah, we'll get hands-on taste of native assets today a little bit right at the end. And agents were going to come a little late in the series in the next 2 to 3 weeks. But yeah, hold on to this idea of participant centricity. It'll pay off about halfway through the session. So what we're going to cover today, I'll quickly go over the slide. Um, we'll start with the toolchain, the pieces that you'll use every day to build on MOI. Then we'll add our first logic together. And the part I'm most excited about is the parallelism story, which is kind of the conceptual heart of today's section. And after that, we go on to actually deploying our logic to the DevNet and verify that it actually landed on chain. We have a few live demos this session, so this isn't just going to be a boring slide-based session. You'll see real code running and actual deployment happening. Please drop any questions in the chat as we go. So I can't actually see the questions right now, but I'm going to stop periodically every 2 to 3 slides to see the questions and answer them in bulk. So if you guys have any questions, feel free to drop it. Okay, so before I jump into the actual content, let me see if there's any questions. Okay, perfect. No questions as of now. Let me get back to the slide. Okay, so this is the overarching workflow that you'll always be using on MOI. End to end 5 pieces. You can either start from step 1 or directly start from step 4, which is something I'll get to in a little bit. But for more advanced use cases, CocoLang is the language that you will use to write your logic and assets on. At a very high level, the compiler takes your Coco code and turns into something called a manifest. Now, for those who build on Ethereum, a manifest is effectively a description of every endpoint. What you can call it's kind of like a it's kind of like bytecode plus ABI rolled into one file for those who've written on Ethereum before. Um, and it's not literally the same thing, but it functionally plays the same role. Next is CocoLab. CocoLab is kind of like Hard Hat. It's like a local testing sandbox. So every logic you write, you can actually register participants. You can and simulate your logics before you actually deploy it to make sure there's no vulnerabilities. To see, if your logics are all sound. You can. It's a local testing environment, which we'll also be working through today. And then we have the js-moi-sdk, which is honestly my favorite part about the entire tech stack. um, you will understand soon why this is. So I think there's something wrong with my screen here. Sorry guys, my screen just stopped sharing for some reason. But yeah, as I was saying, the js-moi SDK is essentially the SDK to take your logic from just plain logic to something that's deployed on chain, and you can do a lot more with it as well. This is particularly a unique part of our tech stack because it it gives you capabilities that no other protocol can give you. For example, you can actually, just a quick sneak peek, you can actually create and deploy an asset on chain just through using the SDK. I'll get to that in a bit. Finally, we have Voyage, which is essentially our DevNet RPC, our our block explorer or testnet explorer, and the testnet faucet. So yeah, I mean, this is the general overview. We can, if you guys have any questions, now is probably a good time to ask. If not, we can get started with the actual demo. Okay, sounds good. So I'm going to quickly run through this slide as well. This is just a quick bit of setup. If you guys want to follow along, this video is also going to be recorded, so you can follow along later. But essentially the steps required to CocoLang are this. I'm going to leave this on the screen for about 60 seconds. If any of you guys want to quickly take a screenshot or follow the steps. If not, we can move ahead. All right. I hope you guys have been able to download it. So yeah, here's where we get started with yeah. Here's the first step essentially. I'm not gonna show this part on the screen, but whenever you want to get started on with a Coco module, you have to essentially write. Yeah, so the first thing you do in any Coco project is essentially scaffold a module. You do coconut in it, and that creates a config file called coco.nut, and then you write your source file right next to it. So the key idea is one module compiles to one manifest, which is one deployable unit. This is clean and simple. And yeah, I'm not going to type this part live. It's just a directory and config file. The interesting part is what goes inside it. So let's look at that. So yeah, this is the first live demo of the session. Um, yes. Okay. So yeah, so this is Flipper. It's about the most simplest useful program you can write up. Um, Up top you have this is the simple what do you call it, the framework or like the outline of any Coco program. It's every Coco program is essentially you have the state and the endpoints that mutate that state, as well as helper functions. Now that's the case for most blockchains or most like programs. um, so yeah, up top we have state logic. This essentially declares our state, like our global variable, which is a mapping that connects a user's identity, which is their address or their cryptographic address, to a boolean that says either yes or no, depending on what the user chooses. Now, this is a very, very simple program. So, suppose I'm Adi, so my value could be yes. Someone watching right now, your value could be no, another person's could be yes. It's a very simple program. All it does is it just flips from yes to no. So this is our state, and these are the endpoints or functions that essentially mutate that state. So the first one is deploy, which is like the constructor sets the default value for any new sender is true, and then we have flip. So what flip does is just changes from true to false, and finally more is just to view the latest value of the boolean. Um, so that's the entire program. It's a state plus three endpoints. Now let's compile it. So I'm gonna go into the Flipper directory. So the first thing I do is Coco compile, and it's compiled. So when you compile your Coco file, as I mentioned earlier, you get a manifest. So flipper.json is that manifest. So essentially, it describes every endpoint and every kind of variable within state. So over here we have um, like it says like we have the logic state and the mapping that we declared as a global variable, and then we have every endpoint also defined within here. So we have flip, which is dynamic and it's invocable. We have mode and deploy. Yeah, so those are the three endpoints. um, yeah, so that's a manifest, and that's the thing we can actually deploy. Now let's actually run it using CocoLab. So the CocoLab was the testing framework I spoke about earlier. So the first thing you do is CocoLab init to get it started. So this is essentially what it looks like. So now what I want to do is I want to register myself as a user or as a tester. So I'll do register Adi. Sorry, can you guys see my screen? I think there's some technical issue. Oh, I guess you can't. Give me 1 second, guys. Let me try to open it. Give me 1 second. Yeah, can you see my screen now? Drop a thumbs up if you're able to see the screen now. Okay, thank you guys. All right, let's continue then. So essentially, what I was showing you earlier was that we compiled the contract and we got the manifest file, which is the ABI plus bytecode. Sure, yeah, I can zoom in. Yeah, and the next thing was we're essentially just testing it using CocoLab. Yeah, yeah, it runs in VS Code, runs in Cursor. I mean, I prefer Cursor, but you can do it in any, right? Um, so to get started with CocoLab, you just start CocoLab init. First thing you can do is I want to register a user to test, so I do register Adi. So this is just like a sandbox user um, registered with like a dummy address. This is not visible on the mainnet on the devnet. This is just visible on my local setup. Um, so what I want to do is I want to test this program out, right? So first thing I'm going to do is after deploying, I'm going to deploy the contract. So deploy flipper.init. Init is the name of our constructor function. And yeah, there we go. It's deployed. Now what I'm going to do is first I'm going to observe what um, what my essential my default value is. So it should be true because it initially is true. So the code for that is observe flipper.logic.values of default user. So one more thing about CocoLab, which is an important detail, is that whenever you get started, whoever you register as the first user, if you start off with CocoLab init, is always the first person you register is always the default sender. So if I hit enter over here, it'll show true. Now to do that again, if I just do values of Adi, oops, sorry, it should be values of this. Oh, that's interesting. I'll check that out. But yeah, yeah. Let me just do that again. So I guess. So yeah, register Adi. I'm registered with this address. Um, I'm going to deploy the contract again, and observe my value. It should and this should show up as true. It's true. Now the first thing I want to do is invoke flipper.flip. So that's the function that essentially changes my state. And yeah, so now it's successfully flipped. Now to verify that it's successfully flipped, we can use the mode function that is essentially just a static endpoint that views the state, like the latest state of a particular variable. So I'm just going to do invoke flipper.mode, and it should show up as false. Yep, it showed up as false. So this is a very simple program that does this. This is just for you guys to get a taste of Coco and what exactly Coco does. But the part that makes Coco really powerful is, I'll show you that next. Yeah, yeah. So the part that makes Coco very powerful is, yeah. So yeah, I mean, just right now, what we spoke about was we ha- sorry, I think there's some problem with my screen sharing again. Okay, it's back. So, okay, let me ask you a simple question. So, think about the values mapping we had in the previous function, in the previous program. A single structure that every single caller and writes into. So, one map shared by you, me, and thousands of other people in the world who want to flip their state at the same time. Now, imagine, yeah. So imagine it isn't just a few of us on this webinar, but it's a million people all hitting flip at the exact same time. So, what has to happen? The network has to essentially lock that map and let people write to it one at a time so they don't clobber each other. So every time I call flip or every time I call mode, i'm in a I'm in a global queue, fighting with millions of other people to sequentially get it done. So only one of us, only one can be processed at a time. um, Three people flipping takes three steps, and million people flipping will take a million steps in order. And that's not a flipper problem per se. That's how most blockchains work. One shared world state, and everybody has to wait their turn in a single line. MOI doesn't have to work that way, and the reason comes back to the word from the start, the fact that we're participant centric. And watch what happens as we move forward when we essentially move the state. So I showed you guys Flipper just now. I'm going to show you a different program called ContextFlipper. It's does this exact same job. The fundamental difference over here is that we start off with something called state actor instead of state logic, and we only have, notice how we only have a single boolean variable over here, right? Earlier we had a mapping that connects each address to a boolean variable, so all of our data is stored in one single mapping, whereas over here each actor is defined just one boolean variable. This state is purely tied to your existence as a participant, which is what makes true parallelism and scalability possible. So let me quickly show you guys an example of how this runs. And before doing that, let me quickly, yeah. So I'm going to do CocoLab init again, and I'll explain each part of the code again. So endpoint endless init is the same as the previous one. It's like a constructor, but again, rather than initializing an entire what do you call it, like entry within a mapping, you're just initializing one person's boolean variable. And same thing with flip. So the first thing I'm going to do is I'm going to register Adi, registering myself as uh, a user, a testing user in the sandbox. Then what I'm going to do is I'm going to do enlist context flipper dot init. So I'm initializing the variable, initializing the program. One second. Sorry, guys, this is weird. Okay, before I get into that real quick, let me just walk you through the differences again. Yeah, so as I mentioned, state logic becomes state actor. Each actor stores its own value and not a shared map. Endpoints, for deployment purposes, they move from endpoint deploy to endpoint enlist. So this is one-time initialization per actor. So it's like deploy, but it's like a constructor, but scoped to each participant. And yeah, finally we have flipper logic becomes context flipper sender. Flipper and context flipper are just names of the logics, but the state is reached to the actor's own context. Um, and yeah, I'll show you guys a quick live demo on this as well. But at this point, do you guys have any questions about what we've spoken about so far? We're just gonna leave the floor open for questions for a minute. How does MOI isolate execution context between manifests? Good question, Kishore. Um, so do you mean for each actor, how does it execute? How does it isolate execution context? Okay. Let me get back to you on that answer. I will drop it on the Moi Builders group chat once I confirm the exact answer to you. So, because I don't want to say anything wrong at this point. But that's a good question. Thanks for asking it. Um, yeah, I'll get back to you on that. If no one else has any other questions, we can get back to the demo. Yeah, okay. So this is the context flipper program we were showing you earlier. First thing we got to do is compile it. So Coco compile, compile. Then we do CocoLab init. Same skit as always. I register Adi. Um, and I enlist context flipper dot init. There we go. It's successfully deployed. So again, what this has essentially done is that it's created this instance for me, for Adi, not for the entire world, not for a shared global mapping. This Boolean variable has only been deployed for Adi's context. Now let's try by actually flipping it and see what happens. So I'm going to invoke ContextFlipper.flip and let's observe the value. Oh, I see what's happened. So give me 1 second. Yeah, we just need to add the mode function over here. Yeah, so I mean that's pretty much it. I just got to recompile the whole thing. Yeah, the only problem here, guys, was the fact that this program didn't have a mode endpoint, which essentially observes the latest state of the user. We have that now, so I'm just gonna deploy this. So first thing is Coco compile. Oh, it should be ContextFlipper. Yeah, there we go. Sorry about that, guys. It's my first time doing a live session in a long time, so bear with me as I do this. It'll get progressively better. So it's compiled. We have the latest ContextFlipper.json. First thing I'm gonna do is test as a CocoLab init, register Adi. Oh, spelling mistake. Register Adi. Perfect. Now I'm going to same thing again. I'm gonna deploy the contract first. So enlist. Then I'm going to I'm going to check my latest value. So I'm going to call invoke context flipper dot mode. Yeah, so it deployed is true. That's perfect. Now we're just going to flip it. And keep in mind, this is all doing it because we have something called a default sender, which is like you can think about it as if I register multiple different actors or multiple different users within this testing sandbox. We can only be actively using one. So right now, I'm like a default, it automatically sets me to Adi. Um, I will show you what happens if that's not the case. So yeah, right now we flipped it. The value should be false. It's false. So the next thing what I'm going to do is I'm going to register another user. So I'm going to register Robert. We get Robert with another address over here. And first thing I'm going to do is set default dot sender Robert. Oh yeah, to first wipe it. So wipe default dot sender. Yes, and then now I said Robert is in default sender. Now I have to do the same thing again. I have to initialize Robert's variable. So I enlist it. His value should be true. And so I'm going to leave his value as true. And I'm just going to show you guys what it looks like if I compare the two values of both. Yeah, so since Robert is set as the default sender, I'm going to show mode. Yeah, invoke mode. It shows his value is true. Now if I wipe Robert, if I do wipe default sender and I set default sender as Adi, and then I run mode again, it'll show me false. Um, yeah, what happens if init is called multiple times? So that's the beauty of this. You can call it multiple times because you're doing it for each individual participant's context. So I'm calling init once for Robert, I'm calling it once for Adi, I can call it once for Kishore, I can call it once for like every single user individually. That's the fundamental idea of participant centricity within my. Whereas if I did it in a global setting, if I did it in a global mapping for flipper.coco, like the other one, I'd only call it once. You only call the constructor once at runtime. Does that make sense? Okay, sounds good. Um, so yeah, I mean that's the idea of participant centricity. At a very very high level, we'll obviously get into specific use cases later. Let me just go back to the slide right now to reinforce the idea. Yeah. So yeah, this is the idea essentially we're going with. If you were to go with the sequential logic state, um, all all state is stored within one mapping or one array, one singular variable or multiple singular variables in one location, right? So every user, every time they want to mutate state or add something to state, they have to wait in line and one by one sequentially, make changes to their state, which is very very inefficient and not practical in the real world. When you use an active state model, the value like active one, so that could be Adi, active two could be Robert, active three could be Bob. Adi mutates his own value, Robert mutates his own value, and um, Bob mutates his own value. So the fundamental idea here is that all three of these activities can happen at the exact same time without needing to wait on one another. This may not be that significant when you look at three people, but imagine applications where a million people are doing this at the same time, right? So that's the real power of active state. And yeah, this is what I was showing you guys earlier. Um, Syntactually, we have pretty much three changes. So logic becomes actor, deploy becomes endless, and logic here becomes sender. Obviously, all of this is within our documentation. It's all very well documented. We have a lot of tutorials, a lot of different places you can actually go try this out. So yeah, uh, this is this is exactly the key idea I was trying to bring about. You have no shared map, and the scale actually doesn't matter in this case. Robert flipping something does not actually change this global mapping, and impact any other data or any other user out there. Yeah, do you guys have any questions at this point? Because okay, just feel free to keep dropping questions as we go. We're almost done with the session. Just a couple more key parts of our toolchain. uh, Next thing we're going to talk about is Voyage, which is honestly really really cool. Let me just share my screen for that as well. Okay, so Voyage is essentially our block explorer, which is this. It shows you all the interactions that's happened. It's our testnet faucet, and we have a bunch of other features also on it, which I will get to in future sessions. But we have something called asset playground, logic playground, RPC playground, and these are really really beneficial and make the testing process for applications so much easier. But what I'm trying to show you over here is um, Voyage is essentially the starting point when you want to deploy actual logic on chain. Every Voyage account comes with a secret recovery phase, and you can also create multiple different accounts per let's say my wallet. And this recovery phase you should not be sharing with anyone. This is the most important lesson. Give me 1 second. Yeah. So if you guys want to take a second to sign up at Voyage.MOI.Technology and ask me any questions over there, you can do that. Um, and grab some testnet tokens. Uh, and yeah, I mean, after this, we only have actual on-chain deployment left. So we're almost done with the session. Thanks for bearing with me until this point. And don't worry, I will show you specifically how to use each one of these four items as well, especially the Explorer. I'm sharing the wrong screen. Okay, let's actually get into on-chain deployment then. We're going to deploy our Flipper contract on Voyage. Um, yeah, so until this point, CocoLab provided Flipper, like proof that Flipper works locally, all the functions are set. Now we run the same cycle, deploy, flip, and read, but for real. We actually deploy it on the blockchain, on the MOI DevNet through the SDK. So there are essentially three scripts. So first thing we got to do is deploy. Let's you know Yeah, first deploy, and then we essentially write deployment scripts for each of the functions or each of the on-chain state mutations we have as well. So that's flip, read, and mode. Um, I'll walk through the code at a very high level. For the first thing you have to do is essentially, oh wait, sorry, wrong screen again. Yeah. So I'll walk through the code at a very high level. Um, So in order to deploy any contract on chain, you need to have a funded MOI wallet, and you need to store that securely in a .env file. I'm not going to show you guys my wallet, so you can't steal my testnet tokens. I'm just kidding. But essentially, the SDK is very powerful. It gives you a lot of functionality that you can do 95% of blockchain activities within the SDK without even touching Coco code. Sorry, guys. Um, yeah. So you're essentially going to be calling three classes from the SDK over here. So one is Voyage Provider, one is Wallet, and one is Logic Factory. Voyage Provider is what you use to essentially connect to the DevNet. Um, Wallet is essentially what you use to sign your transactions. Yeah, Wallet is essentially the package that you use to sign your transactions. And finally, Logic Factory is what you use to actually compile your transactions on chain. And sorry, guys, I don't know what's wrong with the platform today. I keep losing the screen. Yeah, and Logic is what you use to actually, compile your Coco code and put it on chain. It's a very simple program, and this is all you essentially need to deploy the contract, not to actually interact with it. So for deploy, I would just run node SDK. So this is because I've stored in the SDK file. SDK deploy dot js. Sorry, wrong directory again. So I do node SDK slash deploy dot js, and usually takes a couple of seconds. There we go. I mean, yeah, we've successfully deployed this on chain, and let me show you guys how to essentially use this on Voyage. So we have something called logic ID, which comes with every deployment. If I go to Voyage, so what I'm going to do is I've selected interaction over here. I'm gonna, oh, sorry, it's the wrong one. I'm gonna select the interaction hash and paste it over here. And yeah, this is essentially showing that it's been successfully deployed. Um, and yeah, it this is exactly what we need. So the manifest over here is the exact same manifest we compiled earlier. It shows that we've deployed the init function, and this is the same logic ID we have from before. Um, I'm gonna stop the live for a couple of seconds just to try to fix my screen